And sir, we can start.
Okay. Okay. Very good morning to all the participants. I welcome all of you to the third day of the 1 week hands-on workshop on image processing using MATLAB, which is organized by Department of Computer Science and Engineering and Department of Information Technology of St. Xavier's Catholic College of Engineering. Greetings from St. Xavier's Catholic College of Engineering. In the last 2 days, we have discussed some of the concepts of image processing and the MATLAB. That is, in the first day, we discussed about the introduction to image processing, then introduction to the MATLAB, and the matrix operations in the MATLAB and image arithmetic. These are the things we discussed on the first day. And in the second day, we discussed about gray level transformation and image enhancement. Today, we are planning to discuss about the image segmentation and the morphological image processing that help accurate image segmentation. These are the two things we are going to discuss today in this today's session. With this small introduction, I invite Dr. C. Seldev Christopher, resource person of today's session, to start his presentation. Welcome, sir.
Yes, welcome. Good morning to all. Let me share. Is it visible?
Yes, sir.
Seldev sir, one more instruction I want to give the participants.
Yes.
There is an instruction to the participants. See, throughout this session, I request you to mute your audio and as well as video also, because it is a recorded session. We are recording the whole workshop. So if your camera is switched on, your video also will be recorded. So I request you, please mute your audio as well as please switch off your camera also. Thank you. Sir, you can continue, sir.
Okay. Whether it is visible?
Yes, sir, visible. Your presentation is visible, sir.
Okay. So today we are going to see about image segmentation. Right? So how its application, probably we'll see side by side. Some disturbances are there. Okay. So first we will see what is segmentation. Right? Segmentation means that is, you are dividing the image into constituent region. What you have generally, what you can say it is segmenting the object of interest, right? So that's the general, that's the main objective of image segmentation. We are segmenting the object of interest. How it's done using MATLAB? That's what we are going to see. So here, before going for that, what are the segmentation is normally based on intensity level, color, texture, depth, or motion. So based on this four, we can have segmentation. Why is segmentation is why segmentation is very difficult is due to this non-uniform illumination, right? So here, when you are going for any image, in some portion the illumination will be good, some portion illumination will not be there. Right? So in such cases, segmentation will not hold good. So in such cases, first you have to do some pre-processing steps, then only you have to go for segmentation. That is, and also what you can do is, if you are developing a model for segmentation, so that will be useful for just a particular set of images, not for all. right? And also several noises will be there in the image, which makes the segmentation difficult. So the main principle behind the segmentation is there are only two basic properties. One is discontinuity, another one similarity. Discontinuity means, when you are scanning the pixel one by one, so there will be some discontinuity. So based on that discontinuity, we can segment. Or similarity. So what you do is similar object you can group together. Right? That's what meant by similarity. So based on these two properties only, normally you'll do segmentation. Based on the two principles, there are several things that is thresholding. So which converts the image into a binary image, then region based, then edge based, then match based using some template. So all these are available in segmentation. So here when you see this object, right, see this input image. So that we can have different results. See, this is one segmentation, one result. So to segment the object, next individually also we can segment the skin area separately, right? So one example we can give is when you look at the tree from a longer distance, means you can segment only the trees, not the leaf. But when you are going nearer to the tree, we can segment the leaves clearly, not the whole tree, right? So that's what the segmentation differs from our different objects, right? Or from situation to situation, segmentation differs. So accordingly, you have to do, right? So first you are going to see about discontinuity. Based on discontinuity, what are the methods, right? So based on the discontinuities, we are having three types of segmentation. And on the point detection, line detection, and edge detection. So based on this three, based on discontinuity, we have these three. We'll see one by one. So all point, line, edge, three are detected based on the mask only. The mask means in spatial domain only we'll do. So we'll run the mask throughout the image. So in the yesterday class, I told you how to move the mask one by one. So when you are moving, what you do, you multiply the mask content with a particular image content, and you multiply and will add all the values. Right? That will replace in the center value. Right? That's what masking will do. Right? So first you will go for point detection. Right? So for point detection, this is the mask we'll use. Right? So all the element will be -1, the center element will be 8. Right? Suppose if we consider a plain smooth area, all the values are 50. Consider all the values are 50. So if you apply here, what happens? It will become 0. So all the values are 50 means 50. So we'll go for a lesser value. All the values are 5. So we get -5 into -1, -5, plus -5, plus -5. Likewise, if we consider, we'll get us 40. 2, 3, 4, 5, 6, 7, 8. 8 into 5. So -40 will get. So centrally 8 into 5 plus 40. So -40 plus 40, it will become 0. So if it's a smooth area, we'll get value 0. So suppose there is a point there. In the center, we are having a point. So the point value is 10. All the other values are 5, the image. So if you apply the masks now, what happens? So for -5 will get us -40 plus 80. So what you get? You get 40. So what we can say is, when we apply this point detection, we'll have a threshold. So it may be, we'll get us 20 or 30, we'll give a threshold. So above the threshold, we consider there is a point. Below the threshold, we'll say that there is a smooth area. Right? So for that, we can use this particular mask for point detection. right? So you can observe here point. So this is just one example. So we can do it now. In your all of you open the MATLAB and try to do this particular point detection and see whether you are able to do the point detection. So the program, this program is available in the program file, program folder, which is shared to you. Day 3, the first program. Okay? So you click day 3 in the first program. So you just copy it and run it in the MATLAB and just verify it and just put here in the chat window. I have finished. So automatically I'll go to the next. So here in this program you can understand is first you are reading a circuit.diff, then you are giving a mask. What is this mask? So previously you have seen, isn't it? -1, -1, -1, -1, 8, -1. The center value is 8. So all the other values are -1. Next you are creating the mask. Then you know IM filter. So IM filter is used to move the mask throughout the image, right? So that's what you have. IM filter, I comma W. W is the mask. Then you are fixing a threshold 150. So if L is that is the difference is greater than 50, you are considered as point, right? So we can change this threshold. First, you fix it as 150. Only 1 or 2 points will be shown. Just give another value lesser than 150, 100, and just check whether you have got what's the result you have got. So this value of t we cannot fix. That is in general. So if you want to have a dominant points, means you can have or you can fix the t value high. So when you want to get a very small change in, also you have to do mix. You have to make the t value to a lower value, right? So that's what we have to do. Varun sir, can you once again put the program link? So anybody, if you finished the program, just in the chat window, just indicate you have finished the program. Not finished, so that I can move to the next. So try to do it by changing the t value to a lower value and a higher value. So if you move to a higher value, no point will be detected. Right? When you are lowering the t value, you'll get more points. Right? Next we'll go to the next program. Right? Next we'll see the line detection. Right? We have seen the point detection. Now we'll go for line detection. So line means the horizontal, vertical. So line may be in 4 directions. So you have horizontal, vertical, minus 45 degree or plus 45 degree. So normally for that 4 types of mask we can have. Right? So here I give an horizontal mask, plus 45 degree mask, vertical mask, and minus 45 degree mask. So the line can be, if you want to detect the horizontal line, we can use the first mask. If you want to detect the plus 45 degree angle in any line is there, it will be detected. And this mask, the third one, is used for vertical mask, used to detect the vertical line. And finally, minus 45 degree. So you must know how this works. Right? We will see to the horizontal one. Suppose if we have all the values as 5. Suppose if we have a smooth area and all the values are 5. In an image, all the values are 5. So when you apply this mask, what happens? 5 into minus 1 plus 5 into minus 1 plus 5 into minus 1. So minus 15 plus minus, here we will get minus 15. So you get us minus 30, isn't it? Minus 30. Here 2 into 5 plus 2 into 5 plus 2 into 5. So 10 plus 10 plus 10. So minus 30 plus 30. Suppose if it is a smooth area, we will get a value as 0 or value nearer to 0. So you cannot expect all the smooth area, all the values equal values. We will have slight variations. So that one you get nearer to 0 value you get. Suppose there is a line. Consider all the values of 5 and centrally we have a line which is having a value 10. So in such case what happens? So minus 5 into, so here you get us minus 15 plus minus 15 minus 30. So center we are having 10. So 10 into 2, 20 plus 20 plus 20, 60. So 60 minus 30. So we'll get a value as 30. So if there is some variations, we'll get more value. Suppose line is there, we'll get more value, not equal to 0. So from seeing that particular value, we can detect whether line is there or not. So this line is for horizontal, plus 45, vertical, and minus 45. So here, this is the MATLAB code used for detecting the horizontal line. Since in the mask, what we have written, minus 1, minus 1, minus 1. So it is minus 1, comma, minus 1. When you are entering in your MATLAB, you write like minus 1, comma, minus 1 or minus 1, gap, minus 1. So it will take it as a nest element, right? So it looks like it's a 222. It's not the case. 2 separately, a gap is there, 2 and 2, right? Simply we have the value 2 and minus 1, minus 1. So this is the mask we are using. You are applying that mask here, horizontal, right? So IM filter means it is used to move the mask throughout the image, right? So you are showing that L value and I value and L value. So just you run this program. So it is the second program there in the workshop. Program link. So from that you take down the program. So second program, right? where after running this program, just change the W value, that is mask value, so that you first you have detected the horizontal line. Next, whether you are just execute whether you are getting the vertical line. So when you are going for vertical line, just change -2, 2 minus -1, 2 -1, -1, 2 -1, -1, 2 -1. So if you use that particular mask, we'll get the vertical line. Just try to do the MATLAB line detection and just in the so you have executed this line detection, right? Then now just change the mask value. So just change the mask value. So you go for this vertical mask, so that vertical lines will be detected. Right? Just -1, 2 -1, -1, 2 -1, -1, 2 -1. Or you go for plus 45 degrees. Just check -1, -1, 2, -1, 2, -1, 2, -1, -1. Just change the mask and execute, so that you'll be able to understand whether that particular program detects the line. Right? So one has executed, one person has executed and finished. So just change the mask and see, then only you'll understand how it detects the vertical line or horizontal or angle 45 degree. Right? That's what I keep showing the mask here, so that you can change the value and see. So if you have finished executing, I think you must have finished. So we'll go for the next one. The next one is edge detection, right? So here we must know what is meant by derivative, differentiation. So do you know actually what's by the differentiation? So you must have studied about integration and differentiation, right? So here, when you are going for edge detection, you are going to design a mask, right? We are going to design a mask based on two categories, that is first order derivative and second order derivative. That is differentiation. First order differentiation and second order differentiation. That's what derivative you have. Right? What does differentiation actually mean? Suppose if we have a AC in a particular hall, consider you are having AC, right? So what you have in a hall, there are 10 AC. So to make the air cool, right? Centrally a person is there, right? Centrally a person is there, so all ACs are on. Now we'll have some chillness, right? Consider what will be the effect of one AC from that. So if you are switching on the 10 AC, you know the effect. So what is the effect of just one AC? means that's what derivative is. What's what differentiation is? It tells you, if you know a bigger thing, what is a single unit, how that will work, how that is explained by the differentiation, right? So here, differentiation, what will do is it will highlight the region. So in images, what happens is it will highlight the region. So if you are going for second order, means you are going to magnify that little further, right? You are going to magnify it little further. That's what second order derivative is. So here how it's used is, suppose if we have, so this is how the ideal edge will be. So from lower value, if you see the gray level profile, if you have a gray level profile, suppose if we have 0 value and 150. So this is how we'll get, that is the ideal case, it will consider it's a sharp edge. It directly goes from 0 to 150. But when you, in the actual condition, what happens is it will never go from 0 to 150. So what it will do, it will go from 0, 100, then 150, or 0, 0, 50, 100, or 0, 25, 50, 75, 100, 125, then 150. Likewise, we'll get some ramp-like structure only, right? So this is how the in reality will get, right? Ramp-like structure, right? Ramp edges only, right? So what happens is you have to detect both ideal edge as well as if the edges are like this also you have to detect. If the edges are like this also you have to detect, right? Right. So here we'll see what are the first and second order derivative does. So consider here. So this is the gray level. This is the gray level profile. So if you apply the first order derivative, what happens is you will get a spike, right? You will get a spike. When you go for the second order derivative, you get both a positive spike and a negative spike will get, right? So from this, actually, which will show the actual edge clearly. So from this you can say, so here the middle of this one may be the edge. Middle of that particular spike will be the edge. You can say like that. Or starting of this one or ending of this one, right? So it makes you little difficult when you are going for first derivative. So when you are going for second order derivative, so you are getting a positive spike and negative spike. So in between the zero crossing is there. So in your, that's what we call it as zero crossing, right? So here we can fix from zero crossing, we can fix the edge, right? So actually consider when you are getting a sharp edge, always go for first order derivative. That is a gradient function, right? So when you are going for a smooth edge, so edges are blurred, always you try to go for second order derivative, that is Laplacian, right? So now never go for ordinary, that is when the edges are sharp, you never go for second order derivative. Since if you are going for second order derivative, even a small change also will be considered as edge. So over segmentation may occur. So when you are going for second order derivative, since it zooms to a very high level, so automatically a small change also will consider it as edge, right? So if it's a sharp edge, always go for first order. If it is a blurred edge, go for second order, right? So here we'll see first order, you can say it as a gradient operator. If I explain this, it will make more time. So how for gradient operator, what are the masks available? We'll just see that one. So for the first order derivative, we are having the gradient mask. We call it as a gradient mask. Here, there we have Roberts, Prewitt, Sobel. So these are some of the masks used for first order derivative. So you can also generate your own mask. Just when you apply, when there is no edge or no edge, the values will be 0. If there is edge, we'll get more value, so higher value. So from that only you can design by yourself. Nowadays there are several persons who designs the mask by themselves. Some weighted mask, not 3 cross 3. They will design for 5 cross 5 or 7 cross 7, where the accuracy will be more. Even though this Roberts, Sobel, Prewitt is the standard mask for gradient first order derivative, there are several masks you can also design. Right? So here it is used for I have shown only for horizontal and vertical, isn't it? So this is diagonal, Roberts, right? So the same thing you can use for diagonal also. Diagonal, according to that we have Prewitt and Sobel, right? So when you are going for second order derivative Laplacian, we call it as Laplacian. One example, best example is the Canny. Canny, we can say it as a second order derivative. So this is the mask used for the second order derivative Canny, right? So when you are going for MATLAB, it is very easy. That is, for edge detection, there is a separate function. Edge of I, Prewitt. I, you must give the name in single quotation. Prewitt means it will take the Prewitt. If it is Canny means if one are given as first order and second order derivative. Just run this program. We'll see the difference, right? We'll see the difference how the first order and second order derivative works. When the first order derivatives, we can see just the edges will be detected, and in the second order derivative, even the small change also will be considered as edge. That is over segmentation. So just you execute this program, you'll understand. Just try to do. So I can copy it from the program folder. There we have. So if you have finished the execution, just to put it in the chat window, you have finished, so that I can move to the next. Just execute the MATLAB. So you have finished the program. Now you can see, visualize the image, right? So how it is detected, whether it is detected clearly. So just observe Previt and Canny. So in Previt you will get just the coin edges. So here in Canny you will set inside the coin itself, some edges will be detected, more edges will be detected, since that is high sensitivity, right? Since we are going for second order. Right? So we'll go to the next one. Next one is thresholding. Right? Thresholding means, or in another way we can call it as binarization. Thresholding means first what we'll do is we'll fix a threshold. Below the threshold we make it as 0, above the threshold we make it as 1. That's what thresholding is. Right? Suppose if we have a histogram, this is a histogram I have shown. So if we have a histogram like this, we can actually say that, so here this is the background and this is the object. Since background will have more pixel, so you can say, you can fix the threshold in between the background and the object. Right? So we can fix a threshold like this. So and same if you have a dark background with two light objects means you will have a histogram like this where you can fix the threshold. So here and here, two threshold you can have, so that you can be able to detect the two objects. Right? So in practically, whether it is possible, whether you get a histogram exactly like this or this, no. Right? So you'll go for adaptive thresholding. So first you'll finish this thresholding first, right? So what you do is you'll fix one threshold here, isn't it? And above the threshold, you are making it as 1, below the threshold, making it as 0. So how will you fix this threshold? Means first you have to see the histogram and you have to fix by yourself how you can get the p-value, right? So that is that will be difficult. So there are several algorithms there for detecting this threshold. So one such method is the horseshoe threshold. Horseshoe threshold, that is minimum variance thresholding. Right? Minimum variance means what they will do is, in horseshoe threshold, what do you do? So consider this as a histogram. So they first will take the first element and the remaining all element. So first element, the average of all the element, they will subtract. So what will get? So only first two elements and the remaining elements. First three elements and the remaining element. Likewise you do, and will get the minimum mean. So what is the difference? If the difference is minimum, we'll get that as the threshold. So that is horseshoe threshold. So that I given it is in the program. So in this program, you consider you are reading a coin PNG, coin image, and you are fixing a threshold. So level gray thresh is used to get the threshold automatically, right? So automatically I means the image, from the image you are getting the threshold. So here this one is horseshoe threshold. We can call it as horseshoe threshold, right? Next one, after getting the horseshoe threshold, there is a function available, image to black and white. So therefore that function is IM to BW. That is used for converting a image to black and white. So that in that what you do, first you give the image, next the level. So what level you will get there? You will get the threshold. That threshold value will give here. So automatically it will be divided, it will be converted into a binary. So below the threshold it makes the 0, above the threshold it makes this 1. Right? So just run this program. So we can call it as global thresholding also. Throughout the image, you are having just one threshold. That's what you can call by a name, global threshold. Just execute. So after executing, just put it in the chat window. We have finished, so that we can move to the next one. Yes, executed. Right. You must know now binarization. You are getting a binary image. So it's a binary image. You can check it in the workspace. What is the value you can check, isn't it? So you will get 0 and 1 only. Right. You can check it in the workspace there. Right. So this is what we call it as global thresholding or thresholding. So in actual case, suppose if we have a histogram like this, then this will hold good, right? But when you are having a histogram like this, what will happen? It is very difficult to have. Suppose if we have an image like this, we can fix the threshold, right? So if the image is like this, if you fix a threshold, whether it will hold good, no. So you cannot exactly fix the threshold, right? So in such cases, what you do is, we'll go for local thresholding. What is my local thresholding is, so you'll divide the image into small region, right? You'll divide the image to small region, and in each region you'll fix one threshold. So, and you'll convert it to binary using that the threshold value in that particular small region. So after that, you'll go to the next region, I'll find the threshold, and you convert it to binary using that particular threshold. Likewise, you'll do. So that universally, you'll never have a threshold level, or that threshold level that is in locally. That is for each region you are splitted, you'll fix one threshold. So that's what we call it as local thresholding or adaptive thresholding. You can also call it by a name, adaptive thresholding. Right? That's what we call it as adaptive thresholding. Suppose the best example I have given in here. Right? So suppose if we have an object like this, if we use a global thresholding, this is what you get. Right? So you never get the output clearly. Right? So if you are fixing, you are dividing the image into small region, and if you are executing, what happens is you will get a better result. Suppose if you want to get more better result, means you split the region into little smaller, so that the segmentation accuracy will be higher. Right? So that's what you do it in adaptive thresholding. Right? So here I have given a program where what you do is, first you are just reading some image, surface.png, and you are changing that background, so that the background differs. You are getting a background like this, right? So to get a background like this, I just changed that image to I made this particular line, right? for changing that background region, non-uniform background region. After that, what you do, with the next line, what you have done is, you are giving a universal thresholding. That is, universal thresholding you are doing. First step is universal thresholding. Next step is you are dividing this into small region. Right? So if you put colon means the whole, isn't it? Whole row. First one is row. Here is column. So here whole row 1 to 64. Right? So that you can take it into P1. In the second image, you have to consider 65 to 128. So the total size of the image is 256. So you will throw the image column size is 256. So for the next image, you have to consider 65 to. You are dividing the image into small region, 4 region, right? So from 1 to 64, 65 to 128, 129 to 192, 193 to 256. Likewise, you are dividing into 4, right? For all the rows you are not splitting. Just the column wise, you are splitting into 4 segments. And individually, what you do, you apply the gray thresholding. Gray threshold means what? Yeah, the global thresholding. There you use gray threshold is finding the Watershed threshold. So in that region, you find the Watershed threshold. You apply in that particular image, right? That's what it is done in the list 4. 4 types you are done. After that, you are combining all the 4 images. See, after that, you are combining the 4 images. So that will get the image as a whole. You are dividing the image into 4 and performing the local thresholding in each region. After that, you are combining all the 4 regions. That's what done here. Just run this program, you'll understand. Right. So now you must have observed the output, isn't it? Local thresholding, what's the output you have got? Global thresholding, you have what the output you have got. Now, if you compare the second image and the third image, right? So you will get a clear idea that so when you are going for local thresholding, the segmentation is somewhat good when compared with the global thresholding. Right? So next thing, now there are several more methods available, right? Like contour segmentation, then contour-based segmentation, then that is similarity. Based on similarity, there are several methods are there, right? So all this can be all there. If you know the theory behind that, automatically we can use the function from the MATLAB. So later, after finishing this particular program, just go through the help. What are the functions used? Or functions are there in segmentation. So in segmentation, separate functions are there. Just go there and check what are the different types of segmentation functions are available in MATLAB, right? So if you know the theory, we can do it, right? So now we'll skip this segmentation and we'll see how we are connected component analysis. This is the most important part when you are going for segmentation. what is I have divided, I have segmented that image, right? So I have segmented the object, right? So after segmenting the object, what you will prefer is, so how many objects are there? So in that particular image, we are divided into several objects, right? So how many objects are there? Then what's the size of each object there, right? So all this you must take it automatically, so we can do using programming, we can modify anything, and you get you can refer something, infer something from that particular segmentation. So for that only you'll go for connected component analysis. So if you have connected component means how the so one pixel and next pixel are connected. So one object, if you have an object means all that object you have the connected component, right? Then we'll go to the next object, right? So here we are using a function BW connected component. That's the function used for getting the connected component details. And here we'll give the black and white image. Binary image, we will give it as the input. So if we give the input as binary image, automatically this MATLAB, what they do is it will take the properties, all the things that are available in the black and white image or binary image. So here we have the 4 fields are there, which can be incorporated here. So first one is connectivity. So connectivity will have 2 connectivity or 4 connectivity or 8 connectivity. For 3 types of connectivity is there. 2 connectivity means it will go for only horizontal direction. So one pixel is there, similar pixel is available horizontally, then it will take that particular one. It will never see a vertical. So if it is 4 connectivity means it will see only horizontal and vertical connected component. And if it is a 8 connected component means throughout if we have a pixel, so through the we'll have 8 neighbors, isn't it? So if the 8 neighbors have the similar value, then that will be grouped together, right? That's what you have 8 connectivity. So next you will have the image size of that black and white image. Then we have number of objects. So how many connected components are there, right? So that means how many objects are there in that particular image you will be able to know, right? And here, next one you can list. That is from that, if you want to list the first connected component separately, so you will have 10 connected component. So I want to take the first connected component or second connected component. So for taking that, you will get the pixel dx list. From this, you will get one by one. We can take the object one by one. Right? So this is the functions used for that, and also another function which is used under this connected component, that is region props. Region props means region property, right? So what here we will give is region property of that binary image and property. So suppose if you have a binary image and if you want the area of that particular object, automatically it will give the area instance. Area means, so you have 10 connected components means the first connected component is 20, second component is 55, third component is 100. Likewise, this 22 means 22 pixels. Right? It tells you 22 pixels are there in the first object, 50 pixels are there in the second object. Likewise, it will give the area. Likewise, several properties are here. You can see one by one. So if it's just to see, you will understand. So bounding box means, so if you want to have, there is one object is there. So if you want to draw a bounding box on that particular object means you use this particular property. Then centroid of that particular object. Then convex area, convex hull, convex image, eccentricity. So these are all the properties which are available, which normally when you are going for solving big algorithms and all, this connected component analysis will do a major work after segmentation. Okay. So with this, you finish the segmentation. Next, how to fine tune the segmentation. So you have done some segmentation process, right? How to fine tune the segmentation process? That is, for that only we have a separate process called morphological operator. So we'll go to the, I'll open that one. I'll stop sharing this one. I'll open that. Whether it is visible? Yes. So it is visible. Now we'll go for morphological image processing. Okay. So morphological image processing is just used to fine tune the segmentation process. Right. So here morphological image processing has several advantages, right? So what is there is boundary detection. So boundary can be detected using this morphological operator. And these are some of the things: boundary extraction, skeleton, convex cell, morphological filtering, thinning, pruning. So these are some of the things that can be done using this particular morphological operator. So morphology means basically we'll have just two steps. Morphology means just two steps are there. One is dilation, next one is erosion. One is dilation, next one is erosion. Only we have just two things there in morphological processing. So based on this, we'll see, right? So no need for this. I'll go straightly to dilation first. So dilation is the first thing that is available in the morphological processing. So morphological processing are based on some element called structuring element. So the structuring element plays a major role when you are going for morphological operator, right? So consider this as an image, right? And this is an object. So in an image you have segmented one object. So this is an object you have, right? In an image you are having an object. With this small thing you have is consider this as a structuring element, right? So normally we will apply this structuring element in the image. So what happens is this is not the image, this is an object in an image, right? This is the object in an image, not the image. Consider this as an object in an image. With that you are doing a dilation operation. Dilation means what happens. So if you best example you have is, if we say I have a chalk piece, if you put a small one drop of ink, what happens? It just elaborates, isn't it? Right? Are you able to understand that one? It's elaborate. That's the same process this dilation will do. So based on this structure element, when you apply here, what happens is, so the border will be somewhat elongated. How much it will be elongated is based on the structural element. Half of this structural element it will be elongated. So if we have this as 2 or 5, we are having 5 means it will be elongated by 2.5. Right? Likewise, you can say, right? Half the things will be elongated on the 4 sides. Since here we have 4 sides, it will be elongated. Right? Suppose if we have if we have a structuring element like this, we have a structuring element as a square. So now if we have a rectangular structure element like this, what happens is, So if you apply it on the image, what happens here? In the horizontal direction, and we are in the vertical direction, two directions, we are having a higher value here. So that much there will be increase in the object size. Right? So in the horizontal direction, you can see there is a very small change. That change only will be there. So that elongation of that particular object will be based on this structure element you are using. What structure element you are using, accordingly, it will elaborate. It will take a bigger object. Right? So if we have very best example here, you are having this one. So if you use a dilation structure element, see it becomes bigger. Right? So that's the main purpose of this dilation. Okay. So first what you do, we are reading an image, it's a MATLAB code, you are reading a test.png and you are fixing the structural element. You are mentioning here a structural element. So 0, 1, 0, 1, 1, 1, 0, 1, 0. Right? So normally this will be what star structural element. So 1, 0, 1, 0, 1, 1, 1, 0, 1, 0. We can call the stars. So its shape will be in the star. So it can consider it as a star structural element. So how we will do is this, IM dilate the image comma the structural element. If you give, automatically dilation process will be done. Okay? So just execute this program, you will understand clearly what that is. Dilation. After execution, in the command, in the chat window, just write we are finished, so that I can go to the next one. Yeah. So you have got the output. Just compare the input image and the output image. Now then only you will understand what the dilation does. Right? Just compare the input image and the output image. So you can see the letter has become a little bigger. Right? Right. Next, we'll go for. We'll see what are the inbuilt structural elements available in MATLAB. So these are all the inbuilt structural elements. So which are available in MATLAB. So you can have arbitrary. You can give it by own or ball, diamond, disc, line, octagon, tab, rectangle, square. So different structural element you have, right? So instead of having, they are giving your own structural element, you can give. You can give the structural element available in the MATLAB also. So next you'll go for erosion. So erosion means the operation is just the reverse. What is here is if we consider in an image, this is an object, and this is a structured element you have. So when you apply, what happens is the object shrinks. How much time it shrinks is based on the structural element. So this half of this will be shrink based on the structural element. So structural element, you know, from the middle, how much distance you have, that much distance it will be shrink. That particular object will be shrink. So in all the direction, the 4 direction based on the structural element. Suppose if we have a structural element like this, what happens? So the horizontal in a vertical direction it will be shrink by this size. So automatically it will become, the object will become very thin like a line it will become. Right? So that's what structural element will do. So you cannot exactly, roughly you cannot select a structural element. For a particular application, you must know what structural element I have to use. Then only it will be, you'll get an accurate result. Right? And one application of this erosion is, if we have very small object which are under several dots are there in that image, so we can remove the dots. Small objects can be removed using this erosion also. Small objects which are unwanted objects present in an image can be removed from erosion. Right? So the same thing here. Program I have written circle.png, one image I have read. You are getting a structuring element disk with size 11 and apply here. So IM erode image comma structure element, automatically eroded image will be the object will be eroded. Just execute this program. So after execution, you observe the output also, how this object strings. Right? So if you want to just change the size of the disk also, the shrinkage size will be somewhat reduced. Right? Okay. So next we'll go for opening. So this you must understand some principle, that is, opening means, suppose if you are taking from taking an image from a very longer distance, right? So if you are taking an image of a building, 2 buildings are nearby, right? Consider 2 buildings are nearby, and you are taking that image from a very longer distance. Right? From a very longer distance, it looks that the 2 buildings are touching together, right? So it looks like the 2 images, the 2 buildings are touching together. So what happens is you have to split the 2 buildings separately. You have to show separately. In such cases, you'll go for opening. What is meant by opening is, first you'll erode. First you'll do erosion. Erosion means shrinking will do. Suppose 2 objects are touching together. If you erode, what happens? It shrinks, so that 2 objects will be separated. After that, you perform dilation again. So it will elaborate, so that it goes to the original size, but it never touch together. It shows both are as a different object. So first you will perform erosion, then will perform dilation. That's what opening is. So for this, just execute this program and just see. Right. So we have executed the opening. Next one is closing. Right. The same thing we have it as closing. Closing means the same process. Suppose if we have a bridge. So we have taken the image from a longer distance. Somewhat due to some disturbances, it shows that the bridge is broken. It shows from a longer distance, it shows that the bridge is open, the bridge is broken. Suppose in such cases, what you have to do, you have to make the image so that the bridge touches together, so that it shows that the bridge is continuous. So in such cases, we will go for this closing. Closing, what you do is, first you will perform dilation. After that, you will perform erosion. So if you perform dilation, what happens is, it will become bigger size, right? The image will become bigger, so that the two objects will be touching together, make touch together. And after that, when you perform erosion, it will go to the original size, and looks like the bridge is continuous. There is no breakage in the bridge. So this is one application of this closing. That's what closing is. Right? Just execute this one. First, you are generating a structuring element and using a IMClose. IMClose is a function used for closing function. Then morphological closing function. Then original image, comma, the structuring element you give. So automatically IMClose operation will be done. Yeah, closing we have finished, right? So now we will be able to understand what that does. Closing operation, when you see the output, you can visualize the output, right? So when you visualize the output only, you will understand what that does, right? Then we'll go for boundary detection. So I have given a boundary detection. This program is for boundary detection. How you can detect a boundary of an object? Suppose if you perform erosion, what happens? It shrinks, isn't it? So after performing erosion, if you compare with the original object, so the original object minus the eroded image, you will get the boundary clearly. And if you dilate, after dilation, if you subtract with the original object, what happens? You will get some border. So that is the boundary. Okay? So there are four, that you can have four types. That is, you are reading an image, you are getting a structuring element and you are applying iron dilate and erode. Next one, original minus the eroded image, then dilated image minus the original image. Next, last we are having dilated image minus the eroded image. So 3 types of boundary detection we can have, right? Just execute this program, you can see the output clearly, how the boundary has been detected. So if it is a test.png, you can try it for circles.png also. Just change the IM read circles.png, you can easily see how the circles are detected, how edge, that is edge of the border of the circles are detected. So using morphological operator, you can detect the boundary also. So the 3 types of boundary we can detect. First one, that's what I have given here. First property, second property, and third property. Just by dilation and subtracting with the original, and eroded and subtract with the original, dilated minus eroded. Right? Yes, you have executed, right? So now you can detect the boundary, right? Using this property of this dilation and erosion. Next, you go for morphological operator, watershed. So just observe the image here in the left side. That's what watershed will do. So what that does? So what watershed means, you are pouring water. That's what you do. So if you pour water, what happens? You know, when you pour, what you do? You build by yourself using some sand. Just you try to have something and you pour water. What happens? Where and all you are having the sand, remaining area, the water will be there, isn't it? Right? So the same thing, same process only, you do it in watershed. Right? So what you do? You are pouring water. After pouring water, what happens? The lower region gets water. At a certain stage, what happens? You are able to detect the edges. Or segmentation, water based. When you are going for segmentation. So this is what watershed transform is. Shedding the water. And you'll have a stopping criteria so that based on that, you'll finish that one. So you partition into 2 different cells, that is catchment basin and the watershed. Right? That's what you do it in watershed transform. So I have given you here a watershed transform. What here is, I have given one checkerboard. I have created one checkerboard of size 32 and I have added noise, salt and pepper noise. I have added there. In that image, I have added salt and pepper. Why to show you is, you are getting the threshold of both the image. One is checkerboard and the image with noise. Both you perform watershed. So you can see the difference. Just you execute this one and observe the difference. So are you able to see the output? So here in this case, what happens is, what here is, so here when you have a noisy image, even a small white dot is considered as an object. So that's what over segmentation occurred. So that's the main drawback of Watershed, over segmentation. Right? So what we have to do is, normally when you are going for Watershed, you must avoid this over segmentation. Right? So for that only a new method is there, that is marker controlled Watershed. Right? So in marker controlled Watershed, what we'll do is, so we'll mark the edges. That is, see here, read the color image and the grayscale and gradient magnitude. That is, you will mark the background. Right? So we'll mark the background. Right? So after marking the background only, we'll perform the Watershed, so that the segmentation will be visualized clearly. Right? So here this marker controlled Watershed transform, when you are going for MATLAB, you can get it from the help there. So that program is available in the MATLAB itself. Right? So with this, I'll finish this this morphological operator. I will just show you the help there. Right? So are you able to see? So are you able to see? Yeah, you are able to see that, right? Now we'll go for just image parsing toolbox. So in that functions, so what you have studied up to it, we can see here, right? Image type conversion. So gray level converts gray level to binary. So all this conversion will have. Now we'll go to the things we have studied today, right? Segmentation and morphological segmentation. So these are all the morphological operator. I have just given you a small hints. See here, several things are there. Binary hit means operation, morphological operator, binary. This ordinary morphological operator, we have reduce all objects to lines. That is skeleton. Then erosion. Suppress light structure connected to image border. So several operations are there. See here, region map, then watershed transform, what I have told you. So there are several operations in this morphological operator. Just go through in the documentation so that when you are doing any process, it will be helpful, right? And in segmentation, see here, lot of segmentations are there. So active contour, binary image segmentation, right? See here, several segmentations are there. So I have just gone about 10% in that. Right? Only 10% I must have covered. Right? So here, the region-based, then contour-based segmentation. So several things are there. Just you go through. So after completion of this one, this program, just in the evening, just go through this particular all segmentation so that you'll be familiar with this one. Familiar with segmentation in MATLAB. Right? So with this, to finish the today's session. Right? If you have any doubt, we can ask.
If the participants having any queries, you can type your queries in the chat window, or you can unmute your audio and you can ask the queries and get clarified from Seldev sir. So I request the participants to work at home.
So if you are working at home only, if you practice only, it will come. Otherwise, you'll forget after 1 week or 2 weeks. You'll never know how you can run the program or how this particular program works. All this you'll forget. So keep it as a practice. So one question is the boundary and edge. So edges means inside an object also there may be edge. But boundary means boundary of that particular object. Right? So object boundary and edges are different. So in a single object itself, there will be several edges inside that object. That and all we will never consider in boundary. Boundary means the boundary of that particular object. Edges means all the edges inside the object itself will have edge. That will be. So how we can segment iris in an image. So that's what I told you. There is no universal algorithm, segmentation algorithm, or any algorithm in MATLAB that will work for all the images, right? So, so you may be taken one data set or any one image. So if you do ordinary thresholding itself, you may get the iris. Otherwise, in some image, you will never get. So in such cases, you must refer to the algorithms. Different, if you refer any papers based on IEEE or anyone, you just refer the papers and just see whether you are able to get how that particular things done in that particular paper. Andrew sir?
Yes, sir.
Program, they are asking for program.
Yeah, I will share. Dear participants, I have already shared the feedback link. So I request you to enter the feedback also. I have shared the program link also.
Sir, if fuzzy seamings algorithm can segment the lever boundary. That's what I told you. There is no universal algorithm. So in some images, fuzzy seamings segmentation may work. In the same thing cannot be used for some other purpose. Some other say liver image also. In some liver image where the clarity is not good, that seamings may not work. Right? So you cannot exactly say this will work for this particular thing. So watershed transform. So that is used for segmentation. Normally in many medical application, they are using this watershed transform for segmentation. So that means small edges also will be detected. Over segmentation will be there in the watershed. So that can be used in medical application where any small change also you have to notify.
Seldev sir, thank you very much for the wonderful presentation today.
Yes, sir. Thank you. Let me finish now.
Yeah, you can finish, sir.
So I will sign off.
Participants, do you have any other queries? Please ask. Otherwise, we can wind up the session. Seldev sir, we can wait for 5 minutes. If
Okay,
any
sir.
queries are there, we can address that. Otherwise, you can leave.
Okay, sir. The camera is off.
Yeah, you can. Seldev sir, no other queries in the chat window. Sir, so if you want to leave, you can leave. I thank you very much for this wonderful
Things are not leave
presentation.
leave the conversation. Sign off.
Okay, thank you very much. I also thank all the participants on this third day of our 1 week online workshop. Also, I thank my organizers, Engineer CM Varun, Engineer Bright Jose, and Engineer Anthony Jones Kumar. Also, I thank the co-convener of this workshop, Dr. J. Andros, HOD of Information Technology Department. Once again, I thank all of you for your active participation in this online workshop on image processing using MATLAB. So Varun sir, we can stop recording.